Good morning, good evening, everybody. Can you able to hear my voice? Can you please confirm on the same? So next 1 hour, we are going to look into what Spark is all about and why we need Spark, and what's the benefits of using Spark in current big data technology. Okay. So this is Sagar here, and I have prior more than a decade experience in the big data technologies, and also along with that, I work as an enterprise architect, solving most of the Java related problems, and currently work as an architect for big data solutions. And I'm with Edureka for almost a year now, involved in a lot of trainings for big data. And coming back to Edureka, I think most of them will be already aware we are one of the biggest online training providers with a 24/7 support, right? And we are the global leaders in the online training portal today. So without any further delay, I'm going to jump into today's session of basically what is Spark, and why we require Spark. And in fact, most of you might have already heard what makes Spark a very big technology, right? So let me go for a full screen, and so today we'll see some. It's a only 1 hour class, so we can't see the complete future of the Spark. So I'm going to give you an introduction of basically what Spark is all about and why Spark should be used for big data, and maybe going over some of one or two examples of Spark. Okay. The primary objectives of this today's session, as I said, we have very short period, right? We have only 1 hour of time, so we have just taken some of the topics uh, which might bring the context of explaining Spark to a very good extent. Okay, so we are going to start with basically understanding what is big data and what is Spark, why Spark, and Spark ecosystem, and a small introduction to Scala, means why we require Scala and what Scala is all about, and finally also going to do an example of Spark to understand basically how much effectively it's going to perform the better than MapReduce. Okay, so big data, as the name suggests, it's technically is nothing called as lots of data, right? So uh, whenever the term big data comes up, so I think most of you are already aware of what big data is in the market today. So just to give a very short introduction to big data, maybe we can say big data is basically a term which can be simply defined in a simple statement called lots of data. Means when we say lots of data, we are dealing with data with terabytes and petabytes, etc., all the kinds, right? So whenever we deal with lots of data, right, the term lots of data, so the problematic scenario in any big data technologies today, right? So primarily, when you look back, so I'm just sharing my notepad. Whenever the data comes up in the picture, the struggle which we add, and why we come up with technologies like an Hadoop or an Apache Spark, etc., right? So as the data gets exponentially increasing, when I say exponentially increasing, it's in fact increasing in a very faster ratio, right? So one can probably see today, basically we had some, even we are carrying in our hand, in our smartphone, almost a TB of data, right? So it's almost exponentially growing to a very great extent. And down the line, the same discussion, if we have after 5 years, we can easily see that we'll be carrying some petabytes of data also, right? So whenever the huge data comes up, the challenge what we always add is the size of data and the type of data. Okay, that is very much important, because type of data plays a very major role today. We cannot define a particular type. You go to a video, you have an MP4, you have an HD, you have a normal, etc. You come to an audio, you have an MP3. So it's like you come to an image, it's going to be it's going to be a JPEG, it's going to be a PNG. It's like huge, right? The format of the file is huge, right? And again, same thing comes here, right? Down the line, again, the next decade, this is also expected to grow exponentially to a greater extent. So we need a solution for this. Whatever may be the size of data, whatever may be the type of data, can a framework can handle. So that's where Hadoop born. Technically, Hadoop born as a framework to handle this particular problem, right? So without Hadoop, what might have happened? One can easily imagine, right? Without Hadoop, what happened? Let's go for a traditional RDBMS. You are keep forcing me in one particular concept called as tables. Whatever may be the data, you have to stick to a format called as tables, rows, columns, rows, columns, rows, columns. Maybe an image, maybe an audio image, maybe audio file, video file, whatever it is. One common strategy is keep on going and inserting all the data into a tables kind of concept, right? So in order to overcome these problems, physically to overcome these problems, Hadoop won. So Hadoop started suggesting that the Hadoop framework started supporting you can distribute the data in such a way that you can store the data to any extent because the parallel isn't coming up, and you can do analysis on the type of data in maybe any type of data, right? So when we talk on this analysis on the type of data, that's where the MapReduce algorithm came up, and it was a successful algorithm. But MapReduce compared to the database is faster, but technically it's not faster, primarily because of, even though you have this much of distribution, okay, the thing what happened with MapReduce, I just don't want to discuss on MapReduce a lot because that's not our topic today. I just want to say the limitation and why Spark is coming here. So technically, if you look back, what MapReduce tries to say is that, let's consider you are going to work on an 100 GB of data. So what a MapReduce algorithm says, if you are going to split this data and start working on, maybe you can split the data to a greater extent. Means you can split 100 GB into smaller sections of data. Technically, Hadoop splits into a block of data, which is 128 MB. But what the MapReduce started telling is, for each and every processing of data you do, right? So let's consider I started some 10 map process. Okay, as I said, I don't want to discuss on what map process and all. If I started 10 map process, so what Hadoop basically tried to say is that each and every map will be start writing the output to the hard disk, right? So this was causing a big trouble because even though you achieved parallelism to a greater extent, right? You had an 100 GB of data and you basically split the data into a greater extent into a blocks of data. Even though you did this much parallelism, for each and every map process, okay, if my particular solution I'm trying to achieve, for example, I'm trying to achieve a top 10 employees of an organization, whatever you are trying to do. So what's the problem I'm trying to face is that each and every process, the parallel process, if I started 10 parallel process, all the 10 parallel process coming back and telling that I am going to write the output to the disk. All the intermediate process is telling I am going to write to a disk, right? So that's become a bottleneck in a performance. A real-time analytics cannot be done in this way because if you're going to write to the disk and read from the disk, it's going to be a lot of IO constraints, right? One expected to get a lot of IO constraints. So now that's where your Spark came up in the picture. So Spark started telling you very smartly, if you start some 10 parallel process, or let's say you start some 30 parallel process, right? I'm not worried you start a 10 parallel process or you start a 30 parallel process. A typical MapReduce says, for each and every parallel process, what I do, I'm going to write to the disk. Write and read to the disk, right? So the greater technology called Spark born, the same Spark started telling for the same 30 parallel process, what I'm going to do, the Spark comes here. I am also going to write and read, but not from the disk, from the memory. Okay. A thin line of difference. So people think Spark means something major thing came, nothing like that. A very thin line of difference. Thin line of difference is the MapReduce telling for each and every parallel process I start, maybe a 30, 50, 100 parallel process, the interaction between the processes is going to end up in writing and reading to the disk. Spark stepped up and Spark started telling that that's not the way. You have something called RAM. You have something called memory. Why to write to disk? Right? Let's write to read from the memory itself. It's understandable if you're writing the final output to the disk. Yes, it's clearly understandable if you're going to write the final output to the disk. But why you want to write the intermediate process also to the disk? Okay. So this itself is a clear answer why Spark is faster, right? Okay. You're all getting a point, right? What I'm trying to say here, where Spark is trying to fill the gap. Okay, am I right, everybody? Can I get a quick yes? I can also try show you an example how much faster it is going to be. Right? Simple logic, simple terminology. Yes, challenges are more. Means that is yes, Rory. We are going to see a demo. Maybe the first 40 minutes we'll cover the theoretical aspect of Spark, and next 20 minutes we'll go for demo. Fine, Rory. Okay. I am going to show the example in Scala primarily because of we want to show you how Scala looks. Okay, what Scala does. Fine, Srinivas. Yeah. Okay, so now, yes, there are a lot of questions. People can directly ask you a question. What is this all about? You suddenly coming and telling I'm writing to the memory. What happens if my data is huge? My output data is extremely huge. I can't write to the memory. How the memory can? Yes, writing to the memory is a great aspect because you have the concept of cache with you. You can cache the data. You can do to any extent, any level. Everything is fine. But a question can come back again, like a major question can come back is, what happens if the data I'm writing to the memory is huge, right? So that's where Spark come up with a very smart answer called a spill. So what Spark is trying to say, how much the memory can adapt the data, that much data I'm going to provide. And the rest of the data will be spilled into the disk again. Okay, so that's a smarter way of Spark started answer. So going back to the presentation again, so that's what basically telling you exactly what Spark does, right? And what basically the advantage of using why Spark is faster, just to pull you out. Okay, so as we discussed, so we can directly put forward in a very straightforward answer. So Spark is an absolute in-memory computing system. Okay, and it has been completely written in a technology called Scala, and I will tell you why Scala and what Scala is all about, right? And also one more thing, Spark also having a lot of features like Spark SQL, etc. all the thing. Okay, and one important thing everybody has to understand, the moment Spark came up in the picture, people started realizing that Spark is something different. It cannot run in Hadoop. That is totally wrong. Please knock off from the mind. A Spark can run with current version of Hadoop. That is absolutely it's wrong statement. Okay, there is no such thing called Spark cannot run with Hadoop. In fact, I'm going to show you something now. Let me show you something. A very interesting thing I'm going to show you. So whenever you try to download a Spark, so this is the location where I'm sharing the location where I'm going to show you how Spark can be downloaded. So whenever a Spark is getting downloaded, two things you can notice, which is stunning actually. Two things it's absolutely stunning in this page. One is the releases of the Spark. Have a look at this. Every month they have a release. Every single month there is a releases happening in Spark. This is really an absolute picture of how fast this technology is growing to a greater extent. I never seen even Hadoop is getting released like this. Hadoop is the most fastest technology from Apache, but Spark is completely dominating to a greater extent. And this is what I'm keep telling. Spark comes by telling that you can download for which Hadoop version you want. So it is totally wrong. A statement making Spark is different. Absolutely wrong. A Spark can be used for data analytics along with Hadoop itself. So then a question comes, how Hadoop classifies itself from MapReduce as well as Spark. Okay, that's why Hadoop came up with a technology, something called as Yarn. Okay, so people who are realizing why Yarn, this is Yarn. Yarn is something came up. Yarn is smarter enough to understand how to run Spark. If you give a Spark job, it will run Spark. If you give a MapReduce job, it will run MapReduce. That is the beauty of Yarn, right? So you can see most of the current projects which is running with Hadoop with MapReduce can migrate to Spark because Spark can run on Hadoop. Okay, so it's totally responsibility of Yarn to take a call of whether I need to run with an Hadoop or whether I need to run a MapReduce or means Yarn is not only for Spark or MapReduce. Yarn can run even Storm also. Okay, Apart from that, Spark can be run with its own cluster called as Spark cluster, and there is something new things coming up called Apache Mesos, but widely used is basically your Yarn. Okay, I can blindly say that Yarn is the most widely used across everything. Okay, so then going back to those things, the most important slide, a Spark can be built with either your Java, Scala, or Python. That's why we call as polyglot. And but Spark itself is built up with a technology called as Scala. Okay, I'll come there. I'll come there. Why Scala and what Scala is going to provide you a very good thing. Okay, so with Spark, so these are the things you can do. Okay, you can do an nice data analysis. Is going to be faster processing. This is the most important keyword. Okay, real time processing. If Spark is used in real time processing primarily because of it is extremely faster. So when you look back at the Spark architecture, so let me take on the Spark architecture. A very nice architecture we have on Spark. So if you look back at the Spark architecture, Spark itself is not, this is another way people think is that, okay, Spark is only replacement of MapReduce. Even that is wrong. It's not only replacement of MapReduce. Okay, Spark now started supporting machine learning. Means what Mahout does with the help of MLibs. Spark started supporting Spark streaming, which basically your Apache Storm does. Okay, Spark itself is coming with a very greater SQL, which is basically going to make your Hive extremely faster. I don't know how many of you worked with Hive. Hive is basically a technology which is not faster enough, which is in fact a slower way of looking into, but Spark is extremely faster in SQL technologies. And this is not blind DB. This is called Blink DB. Okay, sorry about that. It's a Blink DB, and I'm pretty sure so many of you are aware of R. So Spark also stopped supporting R. So Spark is not only on MapReduce. So two things you have to clarify from this presentation is, one is why Spark. As I said, a smart change done by the Spark by dealing everything in memory. Second thing is, people, as I said, there is absolutely, it's a false statement that by telling Spark cannot run on Hadoop. It's totally wrong. Spark is something which can be easily integrated with current project of Hadoop directly, right? Because of the support of Yarn. The third bullet point is, Spark is not only for MapReduce. Spark can support a lot of other things like the machine libraries and etc. All those kind of things. Okay. Comparing Trace with Spark makes sense instead of Hive. Okay, Neeraj, the Spark SQL is extremely faster compared to Trace, Neeraj, because of everything is going to happen in memory. Fine. So Spark SQL internally uses the Hive context. That's what the point I'm trying to say. Fine, Neeraj. The context which is uses something called as Hive context. Okay. So next, as I said, the first 30 to 40 minutes I'm going to discuss on the theoretical aspect to make sure you got the bullet points on Spark. Then we can go on some of the examples. Scala. This is again a lot of people whenever they see me, they ask the first question: why Scala? That is something called a brilliant language called Java. Okay, all the technologies of Hadoop has been built with Java. So what happened? Why suddenly one of the most cutting edge technology called Spark, which is going to dominate, which is dominating MapReduce to a greater extent. I won't say it's completely dominating because of there are applications which is running with MapReduce which can't be changed. Okay, there are some applications which has to be changed, and the new applications, yes, Spark is the answer. If an important framework called Spark, which is going to dominate the future to a greater extent, which it is already doing, right? We already seen the number of downloads a Spark had, and basically even the number of technologies it started supporting, like the Spark SQL, etc. All those kind of things. So a good question everybody can ask is that why Scala, right? What's the point of going with Scala? Why not Java? Because Java is a greater technology. So the straightforward answer for all of you, why Scala is a functional programming language. Okay. what it's mean a functional programming language. So it means to perform some operations in Scala, one never needs to use objects. Without objects, you can achieve everything with functions. Okay, and people who use Java hate there's something called lambdas. Java 8 has come up with a concept called lambdas. Okay, so Scala is a type of a language which technically uses means the Scala and Java. Both uses JVM. There is nothing changing this. Even Scala uses JVM. Java uses JVM in the backside. But Scala is something which is completely a functional programming language. Means it's not going to depend on objects. Everything it is going to do with functions. And when you work on a distributed system like an Hadoop or a Spark, where you expected to run your particular application maybe in 10 machines, maybe in 20 machines, or maybe in 100 machines. Consider a Facebook kind of thing where it is running in 4,000 clusters, right? If Facebook is having a cluster of 4,000 machines. So wherever you're planning to run in distributed system, there is no meaning of having something called objects, because you don't have any proper relations, right? It's everything is going to run parallelly. When one system is going to differently, or if it's not going to have any relation with another system, then why we need objects? Objects are used to bring some relations, but here everything is going to run in parallel. The first process is not going to have any relation with the second process. The second process is not going to have any relation with the third process. If that's the case, why can't we do everything with functions itself? Why you need to instantiate the class and keep the object? Technically, objects is smarter. Yes, object is smarter because we are going to use something called OOPS, object-oriented principal structure, where you can inherit, abstract, etc. But here you are blindly telling me that a program which is running in machine A cannot run in machine B. It's having no relation at all. This guy is different, that guy is different. Everything is parallel. So that's where basically Scala born, right? So that's why Scala is one of the apt technologies for using in a distributed parallel system. The primary reason is this. The main primary reason is completely why Scala, because it can be used very much smartly in a distributed system, very, very much smartly, right? Because you don't need objects, right? Why you need to create objects and why we need to do all these things, right? So even your Java 8 lambdas, right? It started following this. So that's what even Java 8 lambda does. So whenever you get a time, you can look at your Java 8 lambdas. But this is the primary reason of using a technology called Scala, because it is a functional programming language, which is the best way of using in any distributed parallel system. But telling that it also supports object oriented. It never says I won't support object oriented. Scala also started supporting object oriented, but the backbone of a technology of a Scala is functional programming. They are going to do everything with functions. The primary reason is in a distributed system, you don't need objects. There is no meaning of having objects. Correct? Right? This is not. We are talking about multi-threading. We are talking about multi-processing. Okay, multi-threading means understood. Again, object makes sense. But here we are trying to say multiple JVMs. The one JVM is different, another JVM is different. Each and every machine is going to run on different JVMs. So that's why actually they started thinking, and that's how basically Scala born, right? That's a primary reason of coming up with that technology, something called as Scala, right? So why Scala? Yes, Scala is a functional language, and one more important thing about Scala is it can be easily used with Java. There is no such thing called it cannot. If you have a current Java project already running, right, you can use Scala. As simple as that. If already having a Java project, all you can do is that you can start using Scala very much easily. That's another reason of why we want to use something called as Scala. Okay. So the basic way of doing any real-time analytics today is that, so if you have a big data technology, so what you are going to basically do is that you can sort all of your Hadoop and you can stream it using Spark. So basically we can see an example now with the combination of Spark plus Hadoop. Okay, that's what I'm going to show you with Spark and Hadoop and Scala. how much exactly is going to. Okay. Do we need to know Java to learn Scala? No, no, Srinivas. The answer is straight away no. Okay, the answer is going to be no. There's no such thing. If you know Java, it's an advantage. If you don't know Java, it's fine, not at all a problem. Fine. Okay, that's one of the things. So only one thing I'm going to show you even before starting the example. In next 10 minutes, I'm going to start the example. So let me open up a diagram. So there is no such thing called when you need to know Java while writing Scala, but you should have some knowledge on the programming language. That is enough, because Scala is altogether a new language which you might have never studied before. Also, it's a functional programming language, right? So that's what we take care in our course. See, the only one thing I'm going to take for one more 5 minutes of time is that what I mean by this in memory, right? So what happens is basically, technically, let's say, and this is basically a MapReduce process. So what happens in the case of the MapReduce process is that, so there are a lot of multiple processes running in between the process, I'm going to write to a disk. Okay, so when I'm coming to something called as Spark, so what I'm trying to say is that the same thing when coming to a technology called as Spark, what I'm trying to say is that this guy, instead of writing to a disk, he is going to be in memory. Means what happens is, in Spark there is a concept called as RDD, resilient distributed data set. So what it means is that how it works internally inside the memory means, so let's consider I have a program, I have a particular data analysis I need to do. When I'm trying to do that particular data analytics, or whatever I need to perform a particular data analytics, so what happens, I have identified, let's say I have a use case to find, the use case is find top 10 employees from a data set of, let's say, from a data set of 1 lakh records. So now Spark, what it is going to do, the first things what Spark is going to do is that it's going to generate something called as DAG, directed assembly graph. So what it basically going to do is that is going to first identify what are the steps has to be done. So step 1 may be pass the data like this. Likewise, step 2 may be after passing the data, do some data filtering, and like that, like this, it's found multiple steps. And then comes step 3. Step 3 is basically apply the group by operation to find who's the top 10 employee. And step 4, likewise, it has found something. Step 4. Now after finding this particular directed assembly graph, so what it basically done is that it has come up with a plan. It's not even started the task, it has come up with a plan. The plan is 4 steps. What are the 4 steps? The step 1 basically trying to say is that I'm basically going to collect the data, means the 1 lakh records. The step 2 says let's filter some data, let's consider only the employees of a particular country. Step 3 says okay, let's apply a group by operation to find which is a top performer. And step 4 says then write back the data. Now what happens, now next you have the cluster. A cluster is basically what? A cluster is going to have multiple systems, correct? A cluster might have system 1, system 2, okay, it might be an Hadoop cluster or it may be a Spark cluster, whatever it is. So now what happens, this particular graph will be sent to all the systems. Now let's say system 1 and system 2, system 3 is started processing parallelly all the 4 steps. While processing step step 3, something happened and it got crashed. So what it can do? In the case of our MapReduce operation, in any particular step crashed, we are going to resubmit the job from the scratch. Now, because everything is happening in memory, now what is the advantage is, while processing step 3, something it's crashed, it knows the plan already. What is the plan? Step 1, step 2 and step 3. Instead of starting everything, it can go see what is step 2 and it can come back to start from step 3 because it is already available in memory. That's why the concept of in-memory comes up in the picture. That's why they are called as RDD, Resilient Distributed Data Set. At any point of time, if any particular step is crashed or something went wrong while executing that particular step, there is no need to resubmit the job again, primarily because they can take a step back and they can see basically what that particular step has done before, because they know the sequence of steps and they can start from there. So that's the advantage of using something called as RDD, Resilient Distributed Data Set, in the in-memory. So you don't need to replicate the data like what Hadoop does. Instead, you can always remember the sequence of steps, what's going to happen, and you can fetch back the data from the in-memory from a particular step. So that's why Spark is extremely brilliant. Okay. Getting an idea of what is in-memory, Sudhakar? Yeah, fine. Do we need to learn Hadoop for learning Spark? No, Abhijit. So as I said, right, Spark itself is having its own cluster. Okay, and if you want to run on Hadoop, you can run on Hadoop. It's if knowing Hadoop is an advantage, but the Spark itself is having its own cluster. Abhijit, fine. Okay, yeah. Can I explain in memory one? So that's what I'm trying to say, Shailesh, is that. I just go through this. So what happens is that whenever you are going to start a particular job, it's going to identify what are the steps required for that particular job. Once the moment it identifies all the steps, it's going to send only the steps to all the system. So while executing any one of the step, if anything crash happen, you don't need to resubmit from the step 1 again, because you know what is the flow of the steps, and the data is also in memory. It's in the RAM itself. So instead of starting the job from the scratch, it can go to step 2, get what is the data from step 2 and again start from step 3. So even step 4 is crashed, again it can go to step 3. If not step 3 is available, it can go to step 2. Fine, Shailesh. That's what in memory. Crash means something happens when you're trying to formulate the data. That's what big data is all about, right? The system can crash. They're directly working on the system. Any particular failure means while doing that particular thing, something went wrong and you lost the data. It's not always guaranteed, right? These are commodity hardware systems. Anything can happen. Okay. Yeah. More efficient to run on Hadoop cluster or Spark cluster depends on the requirement, Rory. There is nothing called efficient and all, because a cluster is a cluster. It's not Hadoop cluster or Spark cluster never comes back and told install a new software. They always say the cluster is a combination of the RAM and hard disk provided by you. It's completely depends on your network. So there is nothing specialty like a cluster. End of the day, it's a cluster. Fine, Rory. We will be running mostly on the Hadoop cluster because of the current requirement, right? But I won't. That will be totally wrong to compare the cluster wise, because end of the day they don't have any specific thing, right? What's the difference between Hadoop cluster and Spark cluster? Say a straightforward answer, Kundal. Hadoop cluster is having yarn. It can run Spark jobs as well as other jobs. A Spark can run only Spark jobs. In memory steps, DAG steps also are only the results of the DAG step. Only the results of the DAG steps, and it removes all the other steps, Dinesh. Is DAG similar to what's implemented in test? DAG is a common concept which can be implemented wherever you want, Ashutosh. DAG is a concept which is coming separate. Okay, it's not specific to TASE or it's not specific to Hadoop. It's a common technology. Okay, you can use wherever you want. All other step means, Dinesh, what we're trying to say, it will remember the previous step so that it can go back and get the data from that particular step. If node gets crashed in the middle, what will happen to DAG? Neeraj, DAG is not something. DAG is a flow of, DAG is like a data flow chart, which says You have to do this step 1, then you have to go to step 2, step 3, step 4. So when something gets crashed, it will be having or understanding something like how it can do, right? Basically, it says if step 3 gone crash, you can go and refer to a DAG what before where you have to go. So DAG says if step 3 is gone, go to this particular step 2 and get the data of the step 2 which is available in memory. That's what Neeraj. DAG is not like something like physical data. DAG is a graph which is guiding you how it's going to go. Okay, can you show us architecture Spark cluster? Current time we don't have that much sufficient time to show, Amit, but I can show you in the browser how the Spark cluster looks. Fine, Amit. I'm going to start the Spark cluster and show you that. Okay. For operation standpoint, how frequently one needs to upgrade Spark in production? Nitin, the Spark upgrade is happening because of support of different technologies. If you want machine library, you want to use Spark. It's not like it's changing its current technology, right? Each and every version of Spark is coming back and telling a new technology is getting supported. If you want that particular new technology, update Spark. Otherwise, no need to update Spark again. Fine, Nitin. If the node is down, there's ITR transfer the work to another node. Yes, Neeraj, because it's going to run on top of Hadoop. That's what Hadoop does, right? Okay. So let's go back and look some hands-on. Okay. How easy or tough to upgrade? There's nothing easy or tough to upgrade it. Now we are updating your Hadoop the same way you have to update that. Just you have to update your new software. That's all right. There will be no specific tough thing to do on that. Okay, so time to see the demo. Is it fine, everybody? Can we go and look the demo? You are able to see the VM which I have opened now. Okay, so just to see how much, even before understanding what is Spark, etc. Just a quick example to see how much fast Spark is. Okay, so what I'm basically going to do is that I have started Hadoop, so let's make sure Hadoop is up and running. So let me open up the browser and show you. Okay, so I just want to discuss on more on Hadoop and all. We can discuss in course, just to show you how much fast it's going to happen. So that is, I'm going to browse the file system to see what are the files available. There's something called readme.md. A file which has been pasted, which has been available in my Hadoop cluster. I'm going to do a simple means I'm just going to do a thing. I'm going to find in this particular file which are the line containing the letter A, which are the lines containing the letter B. Means how many lines in this particular file contains the letter A and how many lines in this particular file contains the letter B. So what I'm going to do basically, I'm going to take you the Scala code, which is going to do that particular job. So let me show the Scala code. So just a use case. I'm just taking a count of a use case because count is typically which is tough to do. Always count is the sum which is always takes some amount of time because you have to go to each and every line and identify and understand, correct? So that's why I'm taking this use case. So let's say. So one can see here, I just taken the Scala code. A Scala code is basically completely a functional programming language. This is how it looks. Okay. So what I'm doing is that I'm just reading the readme.emd file, which is available in my HDFS. So once it happens, Scala is a very beautiful code. Okay, means it does everything with function itself. Okay. So if you see here, this is a function actually. A line is a function, and that function is basically going to return. If you pass a line to it, it basically returns what are the line contains here. If you see this particular function, what has been declared here, there is no return statement. Because in Scala, there are a lot of user friendly, like the last line itself a return statement for you. It itself decide what is the return type. There is no way, there is no such thing like void and all to define. If the method is going to return something, you don't need to mention. The last line itself a return for you. If you there is nothing like you need to put a void, etc. all those kind of things. So I'm just basically trying to read a particular file. Okay. And whenever I think most of you know something called as Hadoop configuration, same thing, the Spark is providing a Spark context, which basically provides a complete information of the Spark cluster which is running. Okay. And finally, it's trying to print basically how many line contains A and how many line contains B. Fair enough. So let's go ahead and execute this particular Scala code. So as I seen, right, the code looks so simple. Most of the Scala code will finish in 5 to 6 minutes. So this is a function, this is a function, line contains B is a function, line contains A is a function, again filter is a function, count is a function, 4 to 5 functions coming in one function line. Right? It will be so interesting to study Scala. It means it's a little bit tough to understand because you're watching us for the first time, but once you get practice Scala, right, you love Scala. Okay, and always please, one more thing you all have to understand is it is faster. Okay, means it is Spark will be faster now. I'm going to execute, and also it's Scala can be integrated with Java faster. Okay, so I'm just going to execute this particular job. Let's paste the command, which is the way to execute the particular job. Okay, I have to go to location of Spark. CD desktop, CDs. I'm just going to location where Spark is installed. Guide us how to learn Scala. If you join the course Universe, we have some 4 chapters on Scala itself. Fine, Universe. Okay, I'm just executing the job. The job is to find how many lines is going to have A, how many lines is going to have B. So that's the ultimate intention of this particular line, what we are trying to do. Okay, so it's going to start executing. Okay, so this is the particular intention of the use case, and even before I am telling what is the use case, it has finished executing. It says lines with A is 60, lines with B is 29. Can you all able to see? Can you able to see the output? Just I started execution, we are telling what is the use case, etc. It has finished. Do you want a proof better than this? Spark is faster. I'm running in a pseudo distributed mode, Nitin, because this is a one machine. In fact, if you run in production, it will be tremendously faster than this. Fine, Nitin. This is a single node because I'm running in a pseudo distribution. That's why I'm telling Spark is faster, right? This is a primary example of showing how much Spark is faster. Okay. And one more thing, another advantage of using something in Spark, whenever you use MapReduce, right, you struggle the log, you might have struggled a lot for debugging. So Spark comes with something called as REPL. Okay, I'll just type what is this. REPL. So what is REPL? I'll show you what is REPL now. So REPL, let me show you what is REPL actually. What makes yarn now that is Spark that needs to be executed? The way you submit the job, Sudhakar. While you submit the job, you will clearly say this is Spark job. That's how yarn identifies. Okay, so I'm just show you something called REPL, which is nothing called as a read event print loop. Okay, I'm just opening up Sudhakar. I'm just typing and showing you what is REPL. REPL is nothing called read event print loop. Okay, so what is the advantage of a REPL kind of thing? So now we ran a job, right? So let me open up the Spark shell. Okay, so let me open up the Spark shell. So even we can either open the Python shell or you can open the normal shell. It's up to you. Okay, so let me. So cd space sbin. Okay, dot slash Spark hyphen shell. Sorry about that. bin slash Spark hyphen shell. So I'm opening the Spark shell. So another primary advantage of compared to MapReduce is that the Spark is what is the size of the file that you filed run the letter count? It's approximately something around 30 to 40 MB, Suresh. Around a block size, Suresh. Fine, Suresh? Yeah, fine. See, okay, I have opened the Spark shell. This is called a read event print loop. So the advantage of using something called as a Spark shell compared to your MapReduce program is that you can see or you can also execute some level of the code here. You can see the output here itself. Okay, compared to basically doing with the the same thing with your MapReduce kind of thing. So for example, let me create a simple data set and just try to find, let's try to filter from the data set only finding the element which is mod 2. Okay, so let's say I'm just trying to say I fear I can't, Srinivas, because we have only less time. I'll just try to show REPL, and after this I'll take the questions. Okay, so let's say val of, I'm just declaring a val. This is how the Scala code works. Okay, and Scala will declare something called val because Scala is completely immutable. Okay, so I'm telling val of a sample data equal to 1 to 5000, right? So you can say sample data, you can see the data here itself. What is the data it is having? So this is called REPL, where you can see the output immediately on top of here itself. Now let's say I'm trying to filter all the elements which can be done by a mod 2 of 0. It's fine. So I'm just trying to say sample data dot filter underscore mod 2, means underscore says go through the complete loop equal to 0. So who and all the data can be can be done with help of your mod 2, and print each and every data. So dot for each means iterate over the data, println. This is what Scala can do. In one line it can do everything. Okay, so what this particular line says, see here, this line says take the sample data which is having 1 to 5000, iterate over the sample data, find which is having a mod 2 operation equal to 0. Okay, and go over each and everything and print me the line. So I'm going to enter this. It does that much faster. Spark can work for you. Okay, when you enter this particular thing, the Spark can show you. You can find which are the elements which is having a modulus of mod 2 operation, and it can show you. So that's the advantage of using something called as Spark. Fine. This is interesting, everybody, getting an idea of, I'm just showing you how much REPL kind of things where you can execute the thing, etc. All those kind of things. Okay. So fine, everybody, I can take any of your questions now. So you are getting an understanding of how Spark is all about, and why Spark, etc. All those kind of things. The Spark shell needs to be on the master, or it can exist outside of the cluster. No, Spark shell is just a REPL which you can show which for your practicing debugging purpose. While executing, you will execute the job how we executed in the previous thing, while by coming out and executing. Fine, Sudhakar? If I use the cluster data, yes, if you use the cluster data will be always divided. That is always as usual. If I use the cluster, the data is divided. See, you are going to use the Hadoop cluster only, Shailesh. How the Hadoop cluster is working, the same thing. It will be divided into blocks. The data will be divided into blocks and it will be executed. The same way how the Hadoop works, okay? Best, it will be divided into blocks. Fine, Shailesh? If file is unstructured, then you have to use something called as sequence file. That's not Spark's issue. That's basically there's something called sequence file. You have to consider the concept of a sequence file, and there is a separate concept for handling unstructured data in Hadoop called a sequence file. Spark will work on top of that only. Fine, Shailesh? We have a separate section in course for explaining what happens if a file is totally unstructured. We have something concept called sequence file. Does RDD act as indexing structure? No, nothing like that. RDD is just a concept where what it says, if something went wrong and you can just go back, means you can go to the previous step and identify the data. That's all. In Hadoop MapReduce, output is stored in HDF, a similar way in Spark where output is stored. Sai, I have just taken the data from Hadoop only and I did. The file was in Hadoop. It's not was in Spark. So it will again push the data back to the Hadoop only, right? The data has been taken from the Hadoop cluster. Fine, Sai? It's not taken from anywhere else. Sudhakar, see, that's what I'm trying to say is that if you are going to write, there is a Spark context object you got, right? You've seen the Spark context object. So the Spark context object, if you say Spark context.write, it will write it back to the Hadoop only. Fine, Sudhakar. Just because of the shortage of duration of the time, I was not able to go through all the examples. So what I'm trying to say is that the context will back where the context is going to refer. If it is able to read, yes. If you're telling Spark context.write, it is going to write back on the same, right? If Spark can run independent of Hadoop, that means it's a replacement of Hadoop. It's not like a replacement of Hadoop. What they are trying to provide is they are trying to come up with Spark itself as a separate framework for Hadoop. Okay, but considering the domination of the Hadoop, most of the requirements will be running only Spark on top of Hadoop. Fine, Suresh. But the intention is to come up with a completely a new framework for Hadoop as Spark. So Spark can be run. The point they are trying to say is that Spark can be run independently. Also, Spark can run on top of Yarn also. Fine, Suresh. Yeah. Can you process only required data from a file into Spark? They can pull the data into Hadoop. Yes. You push the data into Hadoop. So that's why I hope you're telling. Can you push the data into Hadoop? Yeah, you can do that. You can do that, Sundar. The Spark has to be installed on HDFS. No, Spark has no need to install on HDFS. Yarn already knows how to do Spark Neeraj. So you don't need to worry about it. Yarn is already aware of to handle the Spark jobs. That's the advantage of having something called Yarn. Fine, Neeraj? I mean, push the, yeah, you can do it, Sunil. So what I'm trying to say is that take the data from the Spark and write the code on the Spark to get whatever the data you want and write it back to the Hadoop. Fine, Sunil. Yeah. Are we saying that Spark can run independently with no Hadoop, or Spark will always need? Okay, Spark is trying to say a straightforward definition, right? It can run without Hadoop. That's the first answer it is giving. But if you want to run with Hadoop, yes, that also can be supported. As simple as that, Sudhakar. What we mean by SVM, Sailesh? I'm sorry, I'm not understanding what is SVM. Support vector machine. I'm not sure that, Shailesh, but if that particular process means, what I'm trying to say is that if that can be gone under the Spark, if that can be run on top of the Hadoop, okay. So how to run Spark without Hadoop? We have to run on the Spark cluster, Nyaneshwar. Okay, that we'll be covering on part of the course, Nyaneshwar. We'll be showing you how to run the Spark cluster, etc. All those kind of things. Okay, to answer Shailesh's question for the support vector machine, yes, machine learning libraries are available in Spark, Shailesh. You can do it. Spark 1.1.0 started supporting this. It's having a nice vector concept. You can do this. Can you integrate Spark to write output to NoSQL database? Yes, Suresh, you can write into HBase actually. Instead of you can write to a NoSQL database called HBase. How good is Spark using Python language? Yes, Sunil, it is really good. It is good actually. You can directly use it. Instead of using Java, you can use it. See, for example, there is something called as Shailesh, there is something called as SVM with SGD in Spark. Okay, it's supporting actually. I can just ping you on your chat window. You can understand that. For your, can you able to see that, Shailesh? Yeah, Spark is having the support. Just taking the documentation and showing you. How you're debugging code in Spark. That's why I showed you the REPL, no, Kondal. That's why I showed you the REPL. Spark is having something called REPL. You can start typing whatever you want in your REPL. Machine learning with Spark will be covered in this course to an extent, Arvind, not fully. Yes, to an extent we will cover. Any preferred approach for scheduling Spark jobs? You have Uzi, Nitin. You have something framework called Uzi which can schedule the jobs. How will you proceed in distributed fashion if not using Hadoop? There is a separate concept called master and worker Neeraj. So that can do the support. Spark is like how Hadoop is having name node and data node. Spark cluster is having a concept called as worker and master. Define Spark in one line. In-memory computing system. Distributed in-memory computing system. Fine, Somadip? So regarding the Spark course, I just want to give a details of the Spark course. So let me open up the you can show you from the Edureka website about the Spark course. So I just open up the website to show you what are the details of Spark courses will be covered. So you can always go back and look at what are the topics in Spark. So basically when you come to the Spark courses, we will show you on introduction to Scala and what are the Scala essentials and what Scala is all about, and going in object-oriented programming Scala, and what about writes. Then we come to a full-fledged of understanding what is Spark and Spark baby steps, playing with RDDs and Spark with SQL, etc. All those kind of things. So we'll be covering these are the things, and you can always contact the support with whatever the discussion you have. Okay. The data can be written with no SQL. Yes, Nitin, it can be written with no SQL, not RDBMS. Fine, Nitin. These are big data. Big data means there is no more NoSQL. Okay, so I hope you all had a very good understanding of Spark. So I request you all is that okay, what's the proposed project for this course? So we'll be you can get all the details about the course by contacting support, Nitin. Fine. So that's why I'm showing you the website of basically what course, etc. all the things. So this is the details of the course. So regarding the course and regarding the course details, etc. and what are the profits we are going to give on all the things, basically you can get the contact with the support and Edureka support, which they will guide you on what are the course details, etc. all the things. Okay. Can we learn Scala and forward about Java? No, Srinivas, nothing like that. There are some scenarios Scala is better, but still when you Java is a huge thing, right? We are speaking in one context called as distributed processing system, but that's not the end of the world, right? After the data is distributed parallelly, there are a lot of things like you have to take the data and you have to produce the data to the web UI, to the web front end, etc. A lot of things is once the data coming out of the cluster, there are a lot of things should be done. Correct. There's email messaging system, there's etc. all the things is right. So there are a lot of things. So we can't don't come to a conclusion like Scala replacement of Java on that. Okay, that's what the point I'm trying to say was. Okay, yeah. Thank you all, and I have a question outside of the topic. Yes, Sudhakar, go with the question, please. Okay, if aggregate data, where the final aggregation happens in master? Yes. The master will get back all the data from the worker and it will produce us the output. Fine, Sudhakar. Okay, so fine. Thank you all. Thank you very much. Yes, I hope you got an understanding of what Spark basically is all about, and why we require Spark and what are the advantages of Spark over MapReduce. So regarding all the course related things and all the concerns, all the discounts, etc. about the course, please contact the support. We have a 24/7 support. You can always contact. Okay. Somdev says we still need the existing technologies. Yes, yes, Somdev. So it's not something, everything is new, right? We always need the existing technologies too. Okay. Output of the Spark will be stored either in the Spark cluster or in the Hadoop cluster side. If you use Hadoop cluster, it will be stored in the Hadoop cluster. If you use the Spark cluster, it will store in the Spark cluster. Okay. Can we say it replaces PI? No. Yes. Most of the big data technologies intention is to replace the BIs only. So fine, everybody. So thanks for attending the session today. Any more further questions, please you can contact the support. They will answer you. And please contact the support about the course related details. What are the discounts provided in the course, etc. All the things. As I said, we always have a 24/7 support with a toll-free number, and you can contact them on the same. And I wish most of you will join the course. And as I said, we have a very good training material program. You can always have a 24/7 support. You have an online training instruction, and you can get a project at the end of the course that also helps you a lot in your career. And please contact the support at the same. And one final request: the moment I finish the session, you will get a feedback. Please kindly fill the feedback at the end of the session. Thank you all. Thank you very much for taking your time and attending the session. I hope you got a very good understanding of what Spark is all about. And I'll meet you all in the Spark course of Edureka. Please fill the feedback at the end of the session. Thank you very much, everybody.